Hi guys, welcome to Basic Bit. Today is Monday, December 14th, and the problem today is called palindrome partitioning. Given a string, we want to find all of the ways that it can be partitioned such that each partition is a palindrome. I'm going to solve this problem using recursion. I'm going to solve this problem using a strategy called backtracking. It's using recursion while storing potential solutions. We check to see if each solution satisfies a certain condition. And if it doesn't, then we can stop searching down that particular path. I think this is most easily demonstrated using a specific example. So we can walk through this example where we have a string with 3 characters. We want to partition it such that each substring is a palindrome. So the first thing we're going to do is we're going to consider all of the substrings that start at index 0. So there's 3 substrings that start there. We could either just have A, or we could have AA, or AAB. And AAB is not a palindrome, so we can remove that from consideration. These 2 are palindromes, so they're stored. And we look at the remaining strings that haven't been partitioned off yet. So if we partition off A, like right here, we have remaining AB. And then if we partition off both A's, we have remaining B. If we only have a substring of B left, we just have to consider whether or not B on its own is a palindrome. And it is. So it can be added to the solution list. So AA, comma, B. And now we've reached the end of the entire string. So this particular partition can be added to our final answers. Along this path, we have remaining a substring called AB. So we can consider 2 things. We can consider, so let's see, let's add in the A that we had from previously. And then we can consider A and AB. And AB is not a palindrome, so this is not a valid solution. A, on the other hand, is a palindrome, so this is a valid solution. We still have 1 more character left, though, before reaching the end. We have the character B. B on its own is a palindrome, so it can be added to the solution. So we have AA, B, and we've reached the end of the string. So this is another one of the valid partitions. So we can store the answers in a list. And I'm going to write a recursive helper function. This helper function is going to take I, which is the start index, and it's going to store potential solutions in a variable called path. And we're going to call helper on a start index of 0, and at this point, path is going to be an empty list. So as long as the start index has not reached the end of the string, we can check all of the substrings that start at the start index. We check if those substrings are palindromes. So a substring would be a palindrome if it's the same in regular order or in reverse order. So if it is a palindrome, then we can add to path, we can add that substring. And we're going to start at the first element following the substring, so that would be J. Otherwise, if we've reached the end of the string, then whatever path is stored, whatever values are stored in path, that's going to be one of the partitions. So we can add that list to the final answer. And finally, we can just return answer. I'm gonna run the code. It finished, looks good.